If you're going to study calculus, you need to watch this video. Calculus is the mathematical study of change, and derivatives play a huge role in calculus because they describe rate of change. This means that they can describe anything from how the gradient changes in a nonlinear function to modeling populations or even working with half-lives and elements. Now, what is a derivative specifically in maths? So, you might know what a gradient is. If we have a line, then the gradient is just how fast that line grows. But if you look at a function that's nonlinear, this is a line, so it's linear, this is nonlinear, you can see that here it's changing very much, here it's changing a little bit less, here it's barely changing, here it's changing downwards, here it's changing downwards even more. So when we find a derivative, we can actually find out how much a function changes at any point. Let's say we have some function f of x. If we take a point x, then this point on the graph will have coordinates x, f of x. Now, let's imagine a small distance called h. This is the distance. So this point will have coordinates x plus h, f of x plus h. Now, a derivative is basically when h becomes a very, very small number, so these points keep getting closer and closer together, and this gives us a new function, the derivative, which tells us the gradient at any point. Now, we said that once h gets really, really small, then it gives us a new function. So let's write out what a derivative actually is. We know that a gradient of a function is y2 minus y1 divided by x2 minus x1. That's kind of the same thing that we're going to be doing here. Basically, we're going to take one of these and we're going to label them y2, x2, and y1, x1. Now, you're just going to write out the formula for a gradient. So at the top, we have f of x plus h minus f of x divided by x plus h minus x. Here on the denominator, we have x plus h minus x, so these x's actually cancel out. And we said that a derivative happens when h becomes really, really small distance. So we're going to use some new notation called the limit. We're going to write it like this. Limit as h approaches, denoted by an arrow, 0 of this is equal to f prime of x, which we call the first, because there's one tick, apostrophe, on the f, the first derivative of the function f of x.